Okay. The question was about when are they going to release checks, and I would never have guessed this would be the issue. That because the our former president, who retired at the end of what was it, August, 1st of September, whatever, uh, his name was on the checks. They are having to reissue them because the new president's name. It would seem like they still be good, but here's the deal. Our old president had been president for something like 33 years or 36 years or something like that. So the last time we had a change of administration was decades ago, and they weren't doing things the same way, and it probably didn't even cross their mind that this was the issue because of course he doesn't sign the checks. They have a stamp. They just do, and evidently no one thought of updating that. I'm not sure I would have thought of it either, but it sounds ludicrous. But maybe I hope that's the answer and that they'll get it all straightened out. I know that early on the problem was this wonderful new system banner that we have, uh, that things weren't working right in it. It seems like a lot of things are not working right in banner. Now, it may be partly our fault because we don't know how to work it, but the other things is they tell us, oh no, that module isn't ready yet, or this isn't the. Well, why do we adopt a system that that's not ready yet? That's still in the beta phase or whatever. I mean, this is nuts, and they forced us to do it this term, which was probably the worst term ever to try to do it. Our first fall term that we're having to do virtual across the board, except for a few hybrid classes and online classes. It's just it. Our administration down in Montgomery is just sort of wacko. They they don't listen to reason, and they're autocratic. Uh, Maybe I shouldn't be recording this, but I am not that unhappy I'm going to be retiring in February. I mean, this is maybe that's why Dr. Ward got out. I don't know. I doubt it, but yeah. Uh, okay. Okay. The only thing is, you're not coming, logging in the class will have absolutely no effect on them. They won't even realize it. Not the ones who need to know. What will get their attention, I think, is if every one of you, and I need to start doing it too, start sending emails like crazy, and say, what is the story on our checks? Where are, and just bugging the fool out of them. And they have a lot of fool. No, I didn't say that, did I? Wait, I think somebody may be coming in. I don't know. Let me see. Oh, you did. Okay. Uh, because frankly, your not coming to class is only going to hurt you. It's not going to touch them at all. I mean, they are so far removed from the classroom or anything to do with really educating students. They are ivory tower up here just messing around with their little whatever they mess around with. And it's, yeah, don't don't shoot yourself in the foot. Cut off your nose to spite your face, or whatever all the things are, because that they won't even they won't even feel it. And if they do sense it, it's going to be somebody else's fault, not theirs. Okay. Well, that's the instructor issue, or that's the blah 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 blah. Never, never do they. I don't know. I hope this isn't getting too political, but it's sort of like Washington D.C. What happens up there, whatever they do wrong, it's never their fault. So um, I don't know. I am so sorry this is happening, and if I can and do have some sort of forum that I can bring this up, I will, and I'll bring it up in spades. I mean, I'll let them know that this is really, really, like you said, affecting students big time. And I'm I am shocked to hear that it's still going on. But that crazy thing about the president's signature, I I it's crazy enough to believe. So I'm sorry. Um, I know I won't have any time at all today because from now until 5:45 I'll be in class, except for two 15-minute breaks and one 30-minute lunch break, and that's all I've got now. My number just went up. Let's see if so. Oh yeah, Kiara's here. Let me get her in. This thing keeps popping up, and I don't know if it's people are chatting or if people are. It's because someone new is coming in. So let me get Kiara here. All right. So we're now up to 20 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Got them. All right, good deal. Good size class today. Hope more will be coming in. Now, any other issues or concerns? We just dropped somebody because now we're down to 19 students. So hopefully they'll be coming back. But that means I have to be watching to make sure I can catch them. You can't, oh, here someone's coming in. I can't see who it is. Brianna is coming in. I don't think she's been here yet. Briantra's here, but I don't think Brianna's been here. Yeah. Let me get Brianna here. Okay. Now let's see what we're up to. We're still up to 20 students, but now I have 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21. So somebody had to bow out, probably their connections or whatever. Here's Chance coming in. Let me get Chance here before they block him. Okay. All right. Okay. So good, Chance is here. All right, so as I was saying, for those who have come in recently, the top question was, what in the world's happening with the checks? And several people have said they've heard that it was because the new president, the old president's signature was on the checks, and they found out they can't do that anymore, so they have to get the new president, who is an interim president, on the checks, and that's what the holdup is. And that sounds absolutely ludicrous, enough ludicrous that it's probably true. Okay, here's Janae. She must have gone out and come back in, so glad she's here. So that should get us up to 22 students. Let me make sure I've got everybody. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Got it. And somebody else is trying to come in, and I can't see who that is. So let me see if I can get them this way. Braxton must have had to bow out and come back in. So now, goodness, this is hard to do. 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 21, 22. Yeah. Okay. I think we got everybody now, and everybody's, I think, back in. Hopefully more will be coming, but let me minimize this. So for those, as I was saying, who just have joined the class, the first several minutes of discussion here have been on where in the world are the checks, and unfortunately I don't have an answer to that, but it sounds like the answer is with the old president retiring, who had been here something like 33 years or something like that, that I guess didn't dawn on somebody that are the checks that are automatically stamped with his signature not are any good. I don't know what the deal is, but they've got to get the mechanism in place for the new president. And by the way, I don't know if any of you know Dr. Anthony, but you talk about someone who is student-centered. She is the person. She's the new interim president. She's been here. She was on the committee, the screening committee that hired me. Okay, she was an associate or assistant dean of students at the time back at Bessemer State Technical College, and she was on the committee that interviewed me, and so you can blame her for that. But other than that, she's moved up. Somebody else has just come in, and I can't see who it is. Shay is here, so let me get Shay in. I don't know if it's Zoom or if it's what. When someone comes in, they block their name. So it's absolutely nuts that they do that, but it's some sort of the package. Okay, it may be, I don't know, it may be whatever, the operating system is or something is doing it. But anyway, that's what this big black box is, that rectangle at the top that's all blacked out. That's where, when someone comes in the class, that's where it pops up, and then it blacks them out. So if I don't see them when they first pop up, I have to go down and find someplace else to do. So we're up to 23 students, I think, now, and I think I've counted enough times. Okay, so anyway, for people who just come in, the discussion has been about the checks. Evidently, there was a problem with them because when the old president retired, no one thought that his signature was going to be on the checks, and that then they were no longer valid or something like that. I don't know. Well, here's somebody else, I think, maybe coming in. No, okay, that was just... Either way you go, they still could communicate that with us, because I mean, they send out emails all day about other stuff. Like, they could say, hey, we're working on it or something like that. Financial aid, or not even financial aid, but Boston State has not sent out anything concerning dealing with our refund checks. Like, not even an email to say, hey, dog, we got them, or like nothing. I know. I certainly haven't seen anything. I agree with you there. I did see emails earlier about the fact that the banner problem, and that they were working on that. I know we had a meeting canceled because the dean was working all weekend trying to help them figure out what in the world was happening with Banner. So I knew there was issue. I don't know what the issue was, but Banner was not doing something properly. So I knew that happened, but that was weeks ago. And this is the brand new one on me, this one that we're talking about now. So yes, I think the communications do definitely need to be improved, but frankly, I hate to say this, that sounds terrible, but the business end of things, they are the worst communicators, I think, of anyone on campus. Maybe it's just because I'm not close to them and stuff, I don't know, but I never, and when we have meetings, they'll stand up there and just go through the same litany every meeting, and we just sit there falling off our chairs because we've heard it 1,000 times. They never change anything, so they just always say the same thing over and over and over again. So I don't know. You're absolutely right, and that is something else I will try to communicate up the stream from me. I had a just real brief conversation with my immediate boss, the associate dean of transfer things, yesterday about something with the spring schedule, but he was in a hurry and just had to get off, and I was busy doing things too, so I didn't. But he is so far removed from it. But I will start making sure I'm going to rattle cages as much as I can, but I'm way from pretty far down the line from where anyone's going to hear the cage rattling, but I'll try to do what I can. All right, any other issues, questions, concerns? Okay, sorry that this is happening, but let's move on. We're in chapter 1, functions in the graph, 1.5, analyzing graphs of functions. And we're in the very last slide, or next to the last slide here. We're talking about even and odd functions. We started this last time, And we did example 8. We're on page 55, and this is example 8, part B. And I hate that they do the whole problem for you, so I'm going to go to the whiteboard and we'll do this so you can actually see how it's, so you can maybe do it yourself rather than just looking at the screen and seeing how they, what they did, not even how they did it. Okay, now I've got to move, you can't see it, but this taskbar is smack in my way, so let me get that moved. And then they've got some sort of a window here that's, they say I'm supposed to move, but of course I can't move it. But I hope it's not blocking anything from you. It's disappeared now, so hopefully it'll stay gone. So here is the problem we're dealing with now. If I can get my pen to show up, there it is. Here's a function. H of x, between me and the pen, it's not doing too well today, is equal to x squared plus 1. Okay? Now, here is always the test for even and oddness. Instead of x, put in h of negative x. That's the test. Whether you're testing for even or odd, that's what you do. Okay? Now, when you put a negative x in here, that's going to mean you do a negative x squared plus 1. Well, what's negative x squared? Well, negative x squared means negative x times negative x. Well, negative times negative is positive, and x times x is x squared, and then plus 1 is still plus 1. Well, guess what? That is exactly the same as h of x. This expression is exactly the same as that expression. H of minus x is equal to h of negative x, it's positive x. That means it's an even function. If you go a little bit to the right or a little bit to the left, the function does the same thing on either side of the y-axis. That's what we mean by being even. If it did exactly the opposite thing, then that would be an odd function. If it does something totally different, neither the same or opposite, that's a neither function. Okay, they haven't shown you one of those, but these were the this was the one they showed. So this is an even function. Now I think the last slide here, any questions on this before I leave this? Let's go back to the book, the slide set. And this is what they tell us. Let me go back to current slide. And they do the same thing we do. They tell you the answer already, which to me is sort of crazy. Okay, they should have said, here's what you do. You put in minus x for x here, evaluate it, see what happens, and you come up with the same thing you had for h of x. H of minus x is the same as h of x, therefore it's an even function. If h of minus x was exactly the opposite of h of x, that would be an odd function. If h of minus x is anything other than exactly the same or exactly opposite, it's a neither function. And they didn't show you one of those. They will show you, I think, oh, and that's the same as h of x. So what they told you up here was the answer already. They're showing you y. It seems like to me they should have shown the y first and then said, therefore this is true. Okay? Now, here is the graph that we were looking at. This was the A part that we did last time. Here's the B part that we just did here. And you see this one, what they've done is drawn the line y equal x here. That's called the identity function we're going to talk about in the next section. They've drawn that here, and you see on the right side, okay, here I think someone else may be coming in. Let me see. No, I don't have anyone else in. Okay, sorry. The thing popped up as if it did. Okay. When you go to the left-hand side, you go down. When you go to the right-hand side, you go up exactly the same amount. Or when you go to the left-hand side, you go up. When you go to the right-hand side, you go down. Exactly the same amount, exactly opposite of each other. That's an odd function. This is the graphical. On an even function, if you go to the right, you get this value. Go to the left, you get the same value. Not the opposite value, the same value. So that makes it an even function for every x on here. Okay? Now an odd function would be a curve that went something like that. You know, it didn't have any symmetry either about the origin or about the y-axis. See, this is symmetric about the y-axis. This is symmetric about the origin. You go the same direction, but in the opposite, the same distance in the opposite direction. Okay. Let me just make sure nobody new has come in. Okay. Now, let me give you a hint to make some of this a lot easier. For polynomial functions only polynomial functions, and these are both polynomial functions here, look at your exponents. Exponent here is 3. Exponent here, when you don't see an exponent, you understand it to be 1. Both 1 and 3 are what kind of numbers? Odd numbers. Look at the exponent here. 2. The exponent here, there is no variable here, so the exponent is 0. X to the 0 is 1. Well, 2 and 0 are both even numbers, so this is an even function. So, now I'll give you one. What if you had a, let's go back to f of x. I haven't used it here. What if you, whoa, come on pen, right, okay. F of x, which is equal to x cubed plus x squared minus x plus 1. I basically took these two and added them together. What you think you've got there? A neither function. Okay? Now here's one reason it's neither. Look at your exponents. They are, someone left, hopefully they'll come back. This is odd, even, odd, even. So that's a neither function. The real test, that's the easy test, is f of negative x would then be negative x cubed plus negative x squared minus a negative x plus 1. Everywhere, oh, here's Weston. So he must have had to go out and come back in because I'm pretty sure I already had Weston here. Yeah, okay. Well, I thought I admitted him, but evidently it didn't take. So hopefully he's coming back in. All right, what we did here, every place that we had an x up here, we put a negative x in its place. Okay, now let's see what this equals. A negative x cubed is negative times negative, that's positive, times negative again becomes negative x cubed. Got a question? Okay. Plus, and this is a negative x squared, that's negative times negative is positive, x squared, minus a minus is plus x plus 1. Now, how does that compare to our original? Well, these two are the opposite, these two are the same, these two are opposite, and those two are the same. That's neither. It's neither the same nor is it opposite. So that's a neither function. most of the functions you'll run into, at least in this course, will probably be neither functions. I won't say that for certain, but they probably will. Only a few of them are going to be symmetric, like these two, and perfectly, well, I'm on the wrong thing, odd or perfectly even. Most functions are going to turn out being neither. Okay, probably beat that into the ground. Any questions or issues or problems with that? Anything that needs to be clarified? Okay, so let's go. I think the next slide says, that's all, folks. So there is a checkpoint right after the example. Please do the checkpoints. In fact, you can probably look at those and do the checkpoint right, because all those are polynomial functions. You should be able to do them right off the top. There is a summary there. That summary is a great review of what we've done in this section. As you see, it covered a lot of really important points. Let's do the vocabulary now. This is on page 56, and that the top 6 questions there. I wish they had it projected. They don't. So I'll read them to you in case you don't have a book. Number 1, the blank 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 is used to determine whether a graph represents y as a function of x. So we're talking about a graph now. What blank 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 do we use to determine whether that graph represents y as a function of x? And if you have your books, you can just turn back one page to that summary at the bottom of the previous page. Number 1 there says anyone know? Folks, it's good to have your books in front of you when we're doing this stuff. Anyone have an idea? The blank 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 is used to determine whether a graph represents y as a function of x. Vertical line test. Okay? Number 2, the blank of a function y is equal to f of x are the values of x for which f of x is equal to 0. So what would that blank be? The blank of a function y is equal to f of x are the values of x for which f of x is equal to 0. What would go in the blank? Earth to class, come in please. The zeros of a function. And that would be number 2 on the previous page on that summary. Okay? Number 3, a function f is blank on an interval when for any x1 and x2 on the interval, when x1 is less than x2, that implies that f of x1 is greater than f of x2. So what would that tell you that function f is doing?
Relative.
Okay, but it's going, if f of x1 is greater than f of x2, the function is going
Vertical.
not vertical, decreasing. Perfect, decreasing. Okay, if the f of x1 was always less than f of x2, that meant you would be increasing. Okay, number 4, the function value f of a is a relative blank of f when there exists on some interval x1 x2 containing a such that this blah 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 such that x1 is less than x is less than x2. That implies that f of a is always greater than or equal to f of x. What would that tell you about that f of a? If f of a is always greater than or equal to the rest of the f's there, that would be a relative. This may have been what you were trying to say before. Maximum. Excellent, excellent, excellent. Okay, number 5. 4 blanks here. The blank, 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 blank between any 2 points x1, f of x1, that would be y1, and x2 f of x2, that would be y2, is the slope of the line through the points, and that line is called the blank line. Okay? A lot of blanks there and a lot of blah, blah, blah there.
Average rate of change.
Excellent. And the line is called the secant line. Secant line. Perfect, perfect, perfect. Number 6. A function f is blank when, for each x in the domain of f, f of minus x is equal to minus f of x. Odd function. Perfect, perfect, perfect. Homework exercises here would include either 7 or 9. They're both at Calc Chat. 9's at Calc View. 11 or 13. They're both at Calc Chat. 11's at Calc View. Any of the odds, 15 to 25, they're all at Calc Chat. 25's at Calc View. Any of the odds, 27 to 31, they're all at Calc Chat. Now they indicate you might need a graphing utility. I think you can probably do that without it, but try it and see. Then any of the odds 33 to 39, they're all at Calc Chat. 35's at Calc View. Any of the odds 41 to 47, they're all at Calc Chat. And again, that indicates you might need a graphing utility, though I think you can probably figure most of those out without one. Okay. Any of the odds 49 to 53, they're all at Calc Chat. 51's at Calc View. So even if you don't have a graphing utility, 51 at least you can see them use one, I think. Okay. 55 through 59, they're all at Calc Chat. 57's at Calc View. 61 and 63, both at Calc Chat. 61's at Calc View. And then 65 is an applied problem. The parts of it might need graphing utility. I think you can probably get by without it. 67 or 69 are both should be at Calc Chat. They both refer to a physics type situation. Any of the odds 71 to 75, that's what we were doing today. Even or oddness, they're all at Calc Chat. 71's at Calc View. Same with 77 to 81, they're all at Calc Chat. 83 should be at Calc Chat. 85 should be at Calc Chat. And then you can do any of the odds 87 through either 87 or 89, they should both be at Calc Chat. 91 or 93 should both be at Calc Chat. 95 should be at Calc Chat, and either 97 or 99 should be at Calc Chat. All right, any questions on 1.5? Another fairly long section, lots of new information there, but now we finally get to a shorter section. So any questions? So I'm going to close 1.5 and go to 1.6. Okay, now I've got to move my taskbars around again. Sorry about this, it's sort of a pain in the neck. Okay, and we should have screen sharing. Y'all can see this, can't you? One thing said I was sharing, the other thing said it stopped. Can you see my PowerPoint? Anybody? Earth to cloud? Yes, good. Okay, good. Let me get it set up for the current slide. We're still in Chapter 1, Functions and Their Graphs. We're now starting 1.6. 1.6 should be a pretty quick and easy section. Let's see if we can move on it. Here are our objectives. We'll identify and graph linear and squaring functions. Okay? We'll identify and graph cubic and square root functions and reciprocal functions. They go something like that. Okay? We'll identify and graph step and other piecewise defined functions, and you'll recognize the graphs of parent functions. That's what we call them. Okay, so let's start with probably the easiest, the linear and the squaring functions. Okay, now where do you think the term linear comes from? What do you think its graph is going to look like? A linear function. A line, exactly. First four letters say line. That's exactly. A squaring function, on the other hand, is going to be, we'll talk about that later, called a parabola. Okay? So one of the goals of this text is to enable you to recognize the basic shape of the graphs of different types of functions. For instance, you know this is a linear function. F of x is equal to ax plus b. Okay? Now, what makes that a linear function? The exponent of the variable. X, you don't see an exponent there, you understand that to be a 1. Any time that you have a function that the one and only exponent for the variable is 1, that's going to be a linear function. A is a constant, B is a constant, those don't really matter too much. It's the exponent of this. If that's 1 and that's the only exponent you have for the variable x, then that's a linear function. Now, we do know something more about this. This a here is exactly what we used to call m, the slope. B is the y-intercept, 0b. It's where x equals 0, and if you put x equals 0 here, this term goes away. You have y is equal to b. So when x is 0, y is b, the y-intercept. And we're used to seeing this y is equal to mx plus b. M is the same as a. That's the slope of the function, the linear function, slope of the line. Okay, so let's think about what the graph of that linear function will look like. What are its characteristics? Well, number one, what's the domain of that function? That line that goes like this or whatever. Domain is all real numbers. There's absolutely no problem with a function that looks like this. There's no denominator, no variable in the denominator. There's no square root involved. That's going to be all real numbers. So the domain is all real numbers. Now, if that slope is not 0, okay, so it has a slope, positive, negative, slight, or greater, doesn't matter, then the range of the function is all real numbers as well, because it can go anywhere. But when that slope is 0, that means the range is just that single value c, okay? If let's call it b, okay? Because if your slope is 0, this term is 0. And you have f of x is equal to b. So your function everywhere, for whatever x you put in, it's always that y-intercept of b, horizontal line. So then its range is only going to be the number b, okay? Now, they didn't say that here, but that's the case. The graph has an x-intercept. Okay, we know the y-intercept, 0b. The x-intercept's a little trickier, but let's just show you why that's the case. Okay, the x-intercept, here's your function. Where is it? Right here. Okay, we'll write it here. Why is my pen not right? Ooh, why did that happen? Okay, here we go. I should say, well, let's just do it. Y is equal to f of x, and this is equal to m, okay, x plus b. Remember, that's your linear function. You could call this a, but they're going to call it m down here, so we'll go with that. And it said that it has an x-intercept. Now, what's the x-intercept? That's where y is equal to 0. So we set this equal to 0, because that's what your f of x or your y is 0. Solve for x. Okay? Subtract b from both sides, and that gives you mx is equal to minus b, and then divide both sides by m. And what's your x-intercept? X is equal to minus b over m, and the y, of course, is 0. So that's where that comes from. Do I sit around and memorize that? No. It's not worth it. So easy to calculate if you need to. Okay? Another issue. The graph is increasing when m is positive. It's decreasing when m is negative, and it's the constant when m is 0. So we know it's increasing, decreasing, or constant characteristics just by studying that m. If m is positive, you know it's an increasing function. If m is negative, you know it's a decreasing function. If m is 0, that means it's a constant function, never changes. Okay. Now, here we have a different kind of issue here. Write the linear function f for which f of 1 is equal to 3 and f of 4 is equal to 0. What does that mean anyway? What does f of 1 mean? That's the y value when x is equal to 1. So this means when x is 1, y is 3. What does this mean? You tell me. Perfect. Okay. Now what can we do if all we know is these 2 points are on this line, linear function on that line? What would this give us? Knowing 2 points on a line, what can you calculate? Yes. Slope, and slope is m. And how does that formula go? Anyone remember the slope formula? Perfect. Perfect. Okay. Now, does it matter which point you name as 1 and 2? No, not at all. Pick either one. Pick one of those y values to be your y2. I don't care which one, just make sure it's a y value. What you want it to be? y2. One of these two y values, choose it to be y2. I don't care which one. 3. Okay. If you choose the 3 to be y2, everything else is fixed. What does the y1 have to be? 0. And if you chose the 3 to be your y2, what's your x2 got to be? 1. And what's your x1 got to be? 4. So what does this give you? Which is? -1. Guess what, folks? We've got the slope. That doesn't answer everything for us, but we got the slope. Now, what does a linear function f look like? F of x is equal to, what does it look like? Remember, previous slide? F of x is mx plus b. You know what m is now. Here is your m. Okay? So what does that mean? We can pick either y value here, and this, remember, is also y, and we know 2 y's here. Pick any one of them. Give me a y. One of those 2 y's up here. I don't care which one. 3, okay? We'll do 3 is equal to -1. Oh, here's Kanisha. She must have had to go out and come back in, because I think I already had her here. Yes, I did. Okay, there's your slope. M is -1. And what x value tags along with this y value of 3? 1. And here's the b we don't know yet. So we're going to solve for b. This tells us that 3 is equal to -1 plus b. Solve for b. So we'll add 1 to both sides, and that gives us b is equal to 4. Okay? Now, go back to your formula here. Y, which is f of x, is equal to mx plus b. Now plug in what you know. F of x, and that's what you're looking for. Find the linear function f, so that's what we're doing now, is equal to m is minus 1, so minus x plus 4. The b is 4. Time out. Let's see if that works. When you put a minus 1 in here, minus x, so minus 1 plus 4 would be 3. That works. When you put a 4 in for x, minus 4 plus 4 would be 0. That works. We are happy campers. There is the formula, the function that stands for, that represents the function f on which these two things are true. Do you see how we did that? We first calculated the slope once we identified those were ordered pairs, and then we plugged that into the linear function form, put that in there, picked one. It didn't matter which one of the points we did, but pick one of those, plug them in, figure out what b is, then put both the m and the b back into that form, and that gave us our answer. Any questions on that? Now, the book may do it, or the slideshow may do it slightly differently, and hopefully you can read through my scratch here. Okay? So to find the equation of a line that passes through x1, y1, and they just named it that way, 1, 3, and x2, y2, they chose different than you did, but guess what? It's going to work out the same. That would be 4, 0. Okay? First, find the slope. Well, the slope, they did just like you did, y2 minus y1 over x2 minus x1, but they used different x and y. Should that make a difference? Well, let's see. The y2 was 0 minus 3, so that's going to be a minus 3. I'm going to go on and do it here. Minus 3 over 4 minus 1, which is 3. And sure enough, that's also minus 1. It just has the minus sign on top rather than the bottom, but it still reduces to minus 1. So it doesn't matter which point you choose to be the 1 point and which to be the 2 point. It doesn't matter. Your slope should come out the same. Okay? And they got the same as I just said, and that gave us negative 3 over 3, which is minus 1. With that then, whoa, Jacaria must have had to leave, and let's see, I make sure that I had marked her here. Jacaria, yes, I had her here already. Okay, next, okay, now they use a different form. They use the point slope form. To me, the standard one was easier to use, but this is the point slope form. Y minus y1 is equal to m times x minus x1. Now, it doesn't matter which point you use again. I guess they'll use the one they named x1, y1. So let's see what happens if they plug it in. Let's see what happens if they plug it in. There we go. Y minus 3, that's the point they said was y1, okay, is equal to m, which is minus 1, times x minus x1, okay. Well, that was the point 1, 3, remember? 1, 3 was there, x1, y1. Doesn't matter which one you use, you'll get the same answer either way. You better, okay? Plug those in, and that gives you, and they skipped a bunch of steps here. Let's fill in the steps here. Y minus 3 is equal to minus x plus 1. When you distribute the minus across there, it changes both signs. Then add 3 to both sides, and that gives you y is equal to minus x plus 4. Okay, so yes, they did it right. Got the same answer we did. So if you want to remember an extra formula and use the slope point slope formula rather than plugging in the one with the formula we were already using, you can certainly do it that way. Both work. Whichever way you do. Whichever point you choose, it'll still work. Any questions on that? All right. So f of x, this is the most important thing to remember in the course. Remember, y is equal to f of x. So instead of y, we put f of x, and that's equal to minus x plus 4, and that's what they asked for. What function f contained those 2 points? And it's real easy to go back and check. Here's the graph of them. Slope of minus 1, meaning it's going downhill, decreasing function. X-intercept is 4, 0. It just happens to be the y-intercept is 0, 4. Sort of unusual for that, but it certainly works. Decreasing function. Now, you tell me, is this an even function, an odd function, or what? This is not in the book. You tell me. Anybody? Even, odd, or neither. This is not an even function. It doesn't reflect across the y-axis. It doesn't reflect across the origin either. So no, this is a neither function. How can we tell? Exponent here is 1. Exponent here basically is 0. So this one's odd, that one's even. It's a neither function. That wasn't part of the question here, but I thought since we had just covered it, we would go back and review that. Okay, any questions on that? All right. There are 2 special kinds of linear functions. The first is, we've already talked about it before, the constant function. It is a line, it is a straight line, and it's the constant function. That one is simply f of x is equal to c, because the slope is 0, so you don't have an mx. That part goes away. Why they didn't use b, I don't know. They changed it to c. Hey, it just stands for a constant, okay? That happens to be your y-intercept b. This looks like that could be about 1.2 or something like that. Whatever it is, that's always 1.2, no matter where you are. Whatever x value you do, the function is always 1.2, or whatever value that is. It's always constant. There's a very special case of a linear function, where the slope is 0. Now, the graph of a constant function is a horizontal line. The identity function, that should be on the next slide, is f of x is equal to x. Now, what does that tell you? The slope is 1, and of course it's a linear function because the exponent is 1, and the y-intercept is 0. Okay? And this should be an odd function because the only term here has an odd exponent, and sure enough, it is an odd function. Okay? When x is 1, y is 1. When x is 2, y is 2. When x is minus 1, y is minus 1. When x is minus 2, y is minus 2. When it goes up on the right-hand side, it's going down on the left-hand side by exactly the same amount. That is your identity function. F of x equal x. In other words, y is equal to x. They're identically equal to each other. Now, if you remember back, this was the on the previous slide. I've already taken that slide set away. Remember, the odd functions always, their points in common were lined up on the identity function. They had that little red dashed line there. That was the identity function. We're going to use it later in the next section or two. We're going to talk about identity function there as well. Okay, so get used to this one. Very special case of a linear function. This one, the slope is 1, y-intercept is 0. It goes to the origin. That's the identity function. Slope of 0, y-intercept anything, that is a horizontal line. So those are 2 special cases of linear functions. Okay, moving on to the squaring function. It's exactly what it says. F of x is x squared. You just take what's in here and square it. That's going to be, they call it a U-shaped curve, and there's a reason they call it that, but I don't really like for them to call it that. But the reason they call it U-shaped curve, it's always rounded at the bottom. Never pointed, always rounded. Okay? So that's why they call it U-shaped. What makes it not U-shaped, a U goes straight up. These always go out. Okay? So it's not quite, it's a mix between a U and a V. It does have the point of a V. It's rounded like a U, but it goes out like a V. Okay? So, but we don't call it a V-shaped curve because it doesn't point. What's the domain of that? All real numbers, because there's absolutely no variable in the denominator, no variable in the square root. So that's going to be all real numbers. The range, however, is always positive, because whether you put a positive number in for x or a negative number in for x, when you square it, it's going to be positive. The only exception is 0. 0 is neither a positive or negative, so 0 squared is still 0. So the answer to that really is always non-negative. You can't say always positive because 0 is a positive, but it's non-negative. So the range is a set of all non-negative real numbers. Up and up, only up and up. That function is even. Yeah, you can tell that. Look at the exponent. The only exponent in the problem is an even one. Okay, so it's going to be symmetric about the y-axis. Whatever it's doing on the right, it does exactly the same thing on the left. Okay, the graph has an intercept at 0, 0, because when x is 0, y is 0. That's its only intercept. Okay, 0, 0. All right. The graph is decreasing on the interval from minus infinity to 0, increasing everywhere from 0 to positive infinity. So there's your increasing, decreasing nature. Symmetric about the y-axis, that was exactly the same as saying the function is even. Okay, so this statement here and this statement here are basically equivalent statements. Okay, and the graph does have a relative minimum at the origin down there. We actually call that the vertex. Now this is the graph of this, and let me go on and tell you what this graph is named. That's called a parabola. We'll talk about that more in the next chapter, but this is called a parabola. You don't need to know that terminology now, but that's that shape. That's the shape of a parabola. I'll go on and spell it for you. That's a parabola, that shape. All right. Now, moving to the next group of functions. This is on page 62, cubic, square root, and reciprocal functions. Okay? Now, the following summarizes the basic characteristics of the cubic, square root, and reciprocal function. We're going to start with the cubic. The graph of a cubic function, now this is a simple cubic function, the most simple. I would call this the cubing function, but they call it the cubic function. F of x equal x cubed has the following characteristics. Domain, again, all real numbers, because there's no variable in the denominator, there's no variable under a square root. So this is going to be no restrictions, all real numbers. The range is also going to be all real numbers, because when you put a positive in here, certainly that comes out being positive. You put a negative in for x, when you cube a negative number, it's a negative times a negative, that's positive, times another negative, goes negative again. So this will have all real numbers for the range. The function is odd. Guess what? Its exponent is odd. Only exponent is odd. So that's an odd function. It also has an intercept at 0, 0, because when you put a 0 in for x, that gives you a 0 for y. Okay? Now let's think about what it's doing, increasing or decreasing. When x is very, very large negative, then x cubed is very, very large negative. And if you get less negative, it's coming uphill. So that's an increasing function till it gets near zero, and at zero it kind of flattens out, but never really flattens out, because then on the positive sign it goes up and up and up. So it's always increasing. Okay? I think somebody must have had to leave because I don't see any new people coming in. Okay? Now, okay. The function is odd because whatever, we already talked about that. Yeah, we've talked about those. We were talking about increasing, decreasing. It's always increasing, and it doesn't have a relative maximum or minimum. It acts like it's going to have a relative maximum on one side, but then it turns and keeps going up. Coming this way, it would act like it's going to have a relative minimum, but it continues going down. So it has no relative maximum or minimum. Let's see what else. Okay, the graph is increasing from negative infinity to positive infinity on that interval for x equal negative infinity to positive infinity, always increasing. Symmetric respect to the origin, that's equivalent to saying it's an odd function. Those two statements are exactly equivalent. Here's what it looks like. Comes up as if it's going to have a maximum here, but keeps going up and then increases quickly. If you were to look right around here, now it looks like it almost is constant there, but it's not. If you take a number really close to zero on the negative side, like negative 0.1, cube it, you get negative 0.001. That's a pretty small number, but it's slightly negative. On the positive side, 0.1 would give you positive 0.001. So it is always increasing, just very, very slowly at the origin, but it's still increasing. Okay, that's the parent function called your cubing function. Now, when you put more terms in here, like some squared terms and linear terms and constant terms, what will often happen is these two separate, and you'll get something that looks like this. That's what a lot of cubic functions will look like, or sometimes like this, like that. They will look like that, and quite often then they will not be even or odd. They'll be a neither function. Occasionally they'll still be even or odd. We saw one earlier that was odd, x cubed minus x or plus x. That was an odd function. Okay, but a lot of times they'll have two humps. This one has no humps. This one will have a relative minimum and maximum. This has a relative maximum and minimum. Okay, it does change, decreasing, increasing, decreasing. This one's increasing, decreasing, increasing. So cubic functions will sometimes do that. The cubing function, that's what I wish they'd have called this one, is always increasing. Doesn't have a relative maximum. All right, now the square root function. Yes, is it time? Oh, how sad, how sad. You bring me bad news. Okay. Where are we? We're going to do on the square root function. So we're on page 62. And by the way, I meant to tell you, you folks that were here early and I wasn't here yet, what had happened, I had extra time. I thought I would check my emails because I had a few minutes, and the first email I hit, unfortunately, was a student in my next class whose grandmother had died, and she said her house was going to be full of people today, so she wouldn't be at class. I thought, oh no. I thought, let me at least say this. And I said, please be safe, be careful. Believe me, I've heard of more when you have large gathering of people, funerals, weddings, just groups of people gathering together. That's where the virus spreads the fastest. So people, if you have anything like that happening to you, I felt like I had to email her back and tell her, please be safe, and encourage your family to be safe. I also express my condolences because I know it's a very sad time, but that's why I was late. Sorry that I was, those of you who waited. Okay. All right, any last thoughts, parting shots before we leave and go? Anything else? Oh, I didn't give you homework exercises. Oh, how could I ignore that? Let me go back and find that. Here we go. 1.6. We didn't get many. 1.6, I think you can do 11 or 13, and you can do 15. Stop there, and we'll pick up the rest of those later. 11 through or 13. 11's at Calc Chat, View. Both of them are at Calc Chat. 15's at Calc Chat. Okay, good deal. All right. Any other things before we leave today? Okay, I'm going to stop sharing. I'm sick and tired of sharing. Thanks for being here. Sorry, I'll try to bring up things about the financial aid. I know the administration is concerned with it. I know they are. They hate for this kind of stuff to happen. They may be actually getting in trouble with Pell Grant, so they are aware of it, and they're going to try to fix it as soon as they can. I'm pretty sure of that. So if there's nothing else, I'm going to end the... Okay, the first test is when we finish 1.6, which I think may be Thursday. So I'll probably post it after class on Thursday. Good question. Any others? All right, then I'm going to end the recording or end the meeting for everybody. So take care, be safe. We'll see you on Thursday. Okay? Bye-bye.